Jens was asking me actually, when was that? Probably around, sometime early spring or something like that, whether I was interested in, coming here and talking a little bit about things. I think he thought about me talking about Qt and what's happening there in the ecosystem. I don't know, but I've been giving, a lot of talks about Qt over the last couple of years. I was really then, thinking, what is it that I want to do? Well, get my PowerPoint to crash. That's a good one. Here we go. And I was then wondering, I've been doing so many talks about Qt. Maybe, it would be great to do a little bit something else. And I was thinking that, I have met a lot of people over the years that have been struggling a little bit with, how do I do my APIs? How do I implement them? How do I do something good there? And I thought maybe, this is something I can do, and that's useful for every developer that we have here. How do I develop my APIs? And just, talk a little bit about my experiences, working on Qt over the last 15 years. So I'll be using Qt a little bit as an example, but I hope it's applicable to everything else as well. But maybe let's start a little bit about why does it matter? Why do good APIs matter? What's important with that? And there's a couple of reasons why this is really important, and it's the heart of what we're doing as software engineers. One of the things is, that code is written once. It's not quite true, you often modify it afterwards, but it's read and modified many, many, many times. And that implicitly leads to the fact that, when we do write the code, we need to write it in a way that allows us to come back to it a year later, 2 years later, or somebody else needs to come back to it a couple of years later, read the code, understand it, and work with it, improve it, modify it. And that's only possible if what you have, the APIs you're using, what you're doing, is actually easy to understand for the other person. Otherwise, you're spending a lot of time doing that and getting back into the code and understanding it. And that doesn't lead to a productive workflow. Your code also often lives a lot longer than you originally planned. I know there's still code in production, out there that has originally been written for these kind of computers, for PDP-11 or other things. So you don't know what's going to happen with your code, and maybe what you are writing today is going to be still in use by somebody else 30 years from now. These people still need to be able to understand what you've been doing and what your intentions were. And, there comes another problem with that we as developers, we rarely document our code. We rarely, write in why we do certain things. And I know that I'm guilty of that. Now, what we can do when we do good API designs and we make this easy is we can reduce that problem, because the code gets easier to understand and easier for people then to come back and look at that code later on, to know what you were intending to do, why you also understand why you were doing certain things as you do. And finally, for your project, I think APIs can be your greatest assets. They can really help you get your job done. They can make things easier for you. And you have your users, whether that's just you're doing inside your team, all the other people that are using the class or the methods that you implemented, or whether it's a greater public like we are doing, where we have a framework with hundreds of thousands of users. They invest into your APIs by learning them and writing code in them. And you can use that to capture them and to make them productive. At the same time, bad APIs can be your greatest liability. You're sitting around with something that you don't know how to maintain, how to improve. People are using your API and they stay there, you're stuck with them, and you're not happy with them because they don't do what you want them to do. They have unexpected side effects, weird behavior, and they can really cause an unending stream of issues roll into you, making your day, blocking you from doing your productive work, from doing new things, and can really block and hamper your process. And as APIs tend to stick around, they stay forever, or at least they are often very, very hard to change, because they tend to, spread out in your project. You'd write a class, and you use it for your own parts, and then somebody else discovers it, say, oh, this is great, I can use this. This simplifies my job, I don't have to rewrite that piece of code myself. So they start using it. And in the end, it's used maybe just in one application, from 50 different places. Or if you're unlucky, it has spread throughout the company and it's being used as a framework from, many different projects. And then, it gets really, really hard to change them without, getting lots of angry phone calls or emails. So you basically have one chance to get it right, and you should use that chance. Well, as I said, somebody might be saying, but I'm just doing an application and I'm working on my own, so I don't really need to be that careful. I don't think that's quite true. You're still designing APIs because good programming is modular. You do create your classes, you create your abstractions, and you want to reuse them and encapsulate functionality. And as your application, what you're doing is growing, you probably might end up working in a team with others. And once others use your API, it really starts getting harder to change it. In addition, thinking about that helps you write better software. That's what I believe. You get a better encapsulation, you have the proper abstractions that you need, and you basically create much more reusable code. So thinking about that from the get-go is something that can be very valuable and help you, move at a faster pace in the long term with your project. Well, let's have some examples about APIs, some stuff that I've had in Qt, and show you a little bit about where, some simple things where I see, APIs that we had and how we improved them because we were not quite happy. The first one we had is in Qt 3, we had a method called find in our QString class. And yeah, it takes an argument and a Boolean. No, who knows what that Boolean does? One person in the back, yes. 2 people. Nobody. It's not intuitive. You don't by reading the code and without looking up the documentation, you have no idea. There's another problem with it. What does it return? Because all of you who are used to using the STL, oh well, it returns an iterator. It doesn't. It returns an integer, an index into the string. So it was in conflict with the common naming conventions that are there in the C++ community. And the bool was about case sensitivity. Now, how could I have known that? So what did we do? When we moved over from Qt 3 to Qt 4 then, we renamed the method. And we had for a long time the old one there as compatibility, but we advocated this one, deprecated the old one. And we basically added an enum about case sensitivity. Now, when you read the code, it's 100% clear. Okay, I'm doing a case-insensitive search in the string. And index of the name is clear because now you intuitively expect this to return an index, an int. You know what it does. So this was one of the things that we did in that respect. And now also the full signature of that method does not surprise you at all anymore. One change, and helps you a lot to get to a clearer API and something that people understand. When they just read the code, they know what it means. They don't have to look up any documentation. And that's a good thing. Another example from Qt 3, QSlider, a slider that you put up as a graphical element. And I don't know what all the arguments do in there. I think I looked it up, so I had an idea. But when I first looked that up again from Qt 3 times, oh God, what does each one of these integers do? You don't really know. In Qt 4, we changed that quite a bit. We said, okay, let's make the API different. You initialize the slider just with one argument with a direction, vertical, horizontal. You could give it a parent. That's the stacking thing for QWidgets or QObjects in Qt. But everything else is more of a property-based API. You set the range. So, that 8 to 128 was actually the range. You set a value, a current one, and you set an object name for the volume. And suddenly you have something code that you can read and understand intuitively. You don't have to look up any documentation to understand what it's doing. So these are important principles that you can then look into and think about how do I want to apply that. And let's now maybe go a little bit away from concrete examples and have a little bit of a look at what makes up a good API actually. What makes an API good and easy to use? And I think there's a couple of common characteristics that we can see. The first one, it's easy to learn and to use. What does that mean? I mean, one thing is, it implements one concept per class or method, and it doesn't mix those. You try to have that clearly separated. You have a string class, it does string handling. You have a button, it does that push button. It's a queue push button and nothing else. It doesn't try to do several things at once. So it does one thing and does that well. The API as a totality has a consistent naming. If you have the same concept, use the same name. If the concepts are different, it's a different name. And you have simple and clear semantics where you don't surprise your users. That means also that, for example, you don't have any unexpected side effects when you call a method. And in the end, it leads to the fact that, you have an API where you can do a lot with that API with having to invest very little into learning that API. Some APIs are very powerful, you can do a huge amount of things with that, but the time it takes to learn those APIs is very large. It's a big investment. Ideally, you can design your class in a way that the investment to learn the API is very small, and you still have all the power that you need. It leads to readable and maintainable code. As I said before, code is written once, but it's read quite often. Worst example here, or one of the bad examples that I know of, is Perl. You write code in Perl, and many people say it's a write-once language. You come back a year later, it's very hard to get back into and understand what the code is actually doing. So you want this to be intuitive. You want to understand what the code does by just looking at and reading it through again. And it's self-documenting. The naming is done in such a way that you understand, just from that, what it does. It's a descriptive naming. I personally believe that for many things, a property-based API makes things very easy to use and understand. And then finally, you hide the complexity in the implementation, and you don't try to not expose it to the user. And you remove the need for any boilerplate code, or as much as possible of that. If you think back about, I guess probably quite a few of you have been using MFC in the past. Maybe some of you still are. And that often, when you use MFC, for example, you often have a lot of boilerplate code that you have to write. And what happens with that is you often, look it up somewhere, Stack Overflow, you take a copy, paste button, and paste it into your application. And in the end, you don't know what it's doing. And it might introduce subtle errors into your code. So removing boilerplate code is good because it improves the readability of the code and helps people, understand what's happening. It also removes complexity and, potential places where you could have errors in your code. It should also be hard to misuse. So, somehow you should make it easy and natural to write correct code. And you encourage good programming practices. So, for example, you don't fail if certain methods, on your class are called in an unexpected order. You don't have to remember that first I need to call foo, then bar, then buts. And if I do it the other way around, things will go horribly bad. And you should not need to be aware of any hidden side effects that methods calls have. Another thing is that failures should be atomic. If you call a function, and then I call it with something that's invalid input in some way or another, I should be notified of that immediately, and not 3 function calls later when I try to do something with that class again. Because then it's very hard to find out where the failure actually came from. It should also be minimal but complete. When you go in and you figure out what does my class actually want to do. You want to satisfy the requirements. You want to cover the common use cases, but you also should avoid adding functionality that nobody is asking for. Reason for that is it's bloats. Usually it's then not tested. You don't get feedback from your users whether it's actually good. You spend a lot of time doing that. It just doesn't help you. And make the APIs as concrete as possible. We always have the tendency to say, okay, I'm doing a framework. I'm generalizing the whole problem. And you generalize it so much that it starts getting very hard to use the API again. So keep things concrete and to the requirements. And then finally, one thing that you need to think about is, okay, now I've done my API. I said, keep it minimal. So, keep the use cases that nobody's asking for right now out of the picture. But then I have to think about what do I want to do in, a year from now, and prepare at least a little bit about what could come in the future. Plan to be able to evolve your APIs over time. And make sure that your API is not in the way for use cases that are not covered. So don't block your users from doing things that your API doesn't cover on their own. Okay, so that's sort of some characteristics of a good API. What about how do I get to get there? How do I design these APIs? The first thing is really to know your requirements. Know what people want with the API. Usually, the best thing is to collect a lot of use cases. Go around, ask your people, ask your users, what do you want? And ask as many of them as you can. But one thing you should be careful about is that often they come up with very concrete requirements. They come and already try to deliver you the solution. So I need this method, or I need this class, and it should be doing exactly that. So what they come is they give you an API specification. Try to get one step back from that, see what is it actually they want to achieve, because often it's not the same thing. And maybe you can, when you look at the different use cases, you can come up with a better solution. And then, I think the next step really, okay, try to specify a little bit the API and define it before you implement it. That's something that I've seen quite often, that people start, okay, let's start with the implementation. We implement something, and then once I have an implementation, I try to figure out what kind of API could I, basically do on top of that implementation that I have. It's usually the wrong way around and can lead to problems, because then you often implicitly hand out and expose any problems that you have in your implementation to your users, because you already have that implementation, you're vested into it. And any difficulties, anything that's problematic with that implementation will get exposed. It's better to start the other way around. Try to figure out what would be the ideal API that I want to have, and then put all the complexity into the implementation. But keep the specification short, make it easy to review for others to review and understand. And in my experience, it's easiest to just do that directly in code. Write the header file. As I said, keep it as concrete as possible. And sometimes there might be some natural generalizations that you can do. Keep an eye out for them, but don't try too hard to just find the generic framework that solves everything. Then look around, in your ecosystem, in your community, in the other APIs that you're using. Are there similar APIs? Learn, understand them, and find the similarities. And if you have something there where the concepts are the same, use the same names. We have, for example, in Qt, we have QString and QByte array. One is a Unicode string, the other one is an 8-bit char array. But many methods in there are actually the same. They're doing the same thing, like index off, case conversions, many other things, and truncating, so left, right, mid. And of course, then the methods are named the same, and they have the same signature as much as possible to make it easy for people to, once they understood one class, they know immediately how to use the other one. That helps. And then, the next step is then to review that API, figure out, does it actually work? So, take your use cases that you have and sketch them out, implement them against the proposed API. Actually write good and realistic example code that uses the API. And this is extremely important, because if you don't really use that API, you will never really find out whether it really works in practice. So write that example code, and it's actually a great basis for your documentation, and it's a great basis for, this further discussions with your users. Does that work? What do you think about it? So that's then the thing, once you have that, you get feedback from as many of your users as possible. And you can iterate that a couple of times, and then, after 2 or 3 times iteration, you usually end up with a pretty good API. I would also recommend that you start writing, some code from day one. As I said, the header file, sketch out the API in code, and write the examples, pretend that it's implemented. There's a good rule that people recommend. That's the rule of 3. You should have 3 different use cases or 3 different examples for the use case that you have, as different as you can make them, to see that the API fits for these examples. If you have some classes that are meant for subclassing or interfaces, write 3 implementations of these subclasses to figure out, does that work? Does it work as I want it to work? That's important, and it might seem like a lot of work in the beginning, but it will really help you and pay back later on. As said, you need to be prepared for extensibility, so think through that as well as a final step. But it's not necessary to do that in the very beginning, but as a final step, you should still think through that. What do I need to do there? And when it comes to that, make sure that all the standard use cases that you have are trivial, and anything else that you want to do, that people might want to do with the API, is at least possible somehow. So what most of the people want to do, the 90% case, should be really as simple as possible. And the other part, make it possible, but don't put too much weight onto making it extremely convenient. One thing to not do is a waterfall design process. I've seen a lot of places where people have been going and, there's an API, we need an API for doing something. And then, there's a couple of people, they go into a meeting room, they close the door, and, they talk through it and write a 100 pages design spec. It really doesn't work. You will not end up with something that you can use and a good API that you will be happy about in the long term. Also, another thing that many people do, you have done your API, you used it for your private thing, and it sort of worked for your use case, and then somebody else asks you, and you start off and publish that to all your users, to the whole company, without reviewing it further, because it did work right in my use case. Also not a good idea, because people will use it very differently and they will have problems with it. Do a review of that API, do the process again. You have a good basis with what you have done as internal API, but you will find things to change. And finally, a big thing, when you have doubts about a certain part of that API, you're not sure whether that's really good enough, whether that's what people need, leave it out. You can always add something, but as I said before, you can rarely remove API. So, this is one of the main things really to remember. When you do something, when you publish APIs to a larger user group, if you're not really convinced this is good and this is helpful, leave it out, have another round of discussion, and maybe publish it half a year later once you're really happy with it. Okay, let's get a little bit more concrete about things. This was really high-level process, something. Let's go into some more concrete examples of what you can do in terms of, how do I name things, and other parts of the process. Naming is really important because names really convey the meaning of an API. And it's really important that you try and spend some time to try to find good names. They should be self-explanatory and clearly communicate the purpose of your API. If you have a method that has side effects, the name should communicate that, so you don't surprise your users. And you should match the method signature really to the name as well. That should match together. There's also another thing that you should look at is look at your target audience. If you develop for an API for a bunch of mathematicians, you probably can assume different things than if you write an API for an electrical engineer or for a computer scientist, for that matter. So think about your audience, what they will intuitively understand, what they think about. And one more thing, if you can't find a good name, then take a step back and think about whether the concepts that you have are actually good enough. Because it usually shows that if you can't find a good name that matches what your API does or what your class is supposed to do, that maybe that I could do something different. I could split up that class into two, or refactor something, change the concepts a bit so that the name becomes and the meaning of that class becomes clear. Really make names also specific. I've seen lots of people, as I said, you have a tendency to write frameworks to generalize things. But I think it's really good if you can try to make names as specific as possible for your purpose. It helps people to understand and what the class does. At the same time, it's also a good measure because general names, they eat up your namespace. We had a case, for example, in Qt where we had in a Qt 3D, which is a rather sort of, not a very core module, and they had a class called QArray in there. And that's a very generic name. And, it was for a class that was actually a rather special purpose. That doesn't really help us. So, that's something we wanted to change and we didn't want to have because it pollutes the global namespace. And it takes the very generic name away from something that where you might need it in the future. Also make them unambiguous. Often, you have something where you have slightly different concepts, and then people still choose the same name because it's almost the same, but it might really lead into problems for people then to understand what it exactly does. So if the concepts are different, really choose different names. As we have here now, you have if you do sending events, for example, it's a common thing in event-driven, APIs that we have. And you could send one and it will be delivered immediately, or you put it into a queue and you deliver it later. And, the two methods that should do that should be different. It's send event now versus send event later. And certainly not send event with an event and then a Boolean, do it now. That's really bad. In Qt, we have done a slightly different solution. We have, send event and post event. Like, sending is like email, pretty much immediate. And posting, you go to the post office, you have to wait a long time. Can discuss that, but it's there, has been there for a long time and for historical reasons. Another thing is to really avoid abbreviations. They're very tempting when you write your initial version of the code because you have to type less. But as I said, you write it only once, you read it a lot of times, and they lead to less readable code. Also, nowadays, when you write your code that uses the API, you do have completions in your IDEs. So abbreviations are really not that needed anymore. And we're not doing Fortran where we can have max 7 letters or something like that for function names. So let's write that out and make really readable names without, abbreviations. There's some exceptions like, common abbreviation, min and max, for example, you could use that. But then you should use them consistently all over so people get used to them and they know it's always that abbreviation. There's something that we have been doing wrong in Qt as well. And we have qdir, and then qFileDialog has a method setDirectory, not setdir. It's not consistent. So you always have to look that up when you write your code. One thing that's okay usually is acronyms, because people do know them and understand them immediately. XML Stream Reader is one of these that we have. Okay, everybody knows, okay, that's XML, and it reads from a stream, reads that XML in and passes that. On the semantics, it's the next thing you need to look at when you do APIs. So naming is one piece, semantics is the second piece, and they play hand in hand, they belong together. But it's really about choosing good default. One of the things is about choosing good default behavior. Default to what your users, or what you would intuitively expect your API to do. Usually that means you need to turn off all the bells and whistles by default. Boolean properties, make them false by default. An example here is, comparing qpush, what we have in qpush button, where we say, okay, we do a push button with a text. That's the text that the button will display, and a parent, which means, that's where you embed it. And then the other API is from Coco. And there you see, one thing they do very well here is actually, it's also a property-based API. You see that you have methods for everything that you initialize. But the defaults are wrong. I mean, why do I need to do a dummy rect here? I have no idea, but you need to do it. Why do I need to set the button type? I want a standard-looking button, the one that looks like a standard button on a MacBook. But I still need to set that button type and the bezel style. Don't ask me why. So there's basically at least 3 lines of things where you initialize and you set something up to actually match the default behavior that you would want to have. That's something that we want to avoid. The default should really be selected the right way. Another thing, in the early days of Qt, we've been, pretty guilty of that actually. We've been trying to add magic to our methods. Saying, okay, we can auto-detect certain things. Like we have this QLabel where you could set a text on it. And you pass in a QString, and we would automatically detect, oh, this is HTML. Let's pass this and display it as rich text. But it really is difficult because it leads to subtle side effects. Sometimes that detection wasn't 100% reliable. It was HTML being passed in, we understood, or we thought it was plain text, showed it as plain text, or the other way around. Or people wanted to show HTML as plain text. And then they had problems doing that. So we changed that then and said, okay, let's be explicit. You set the text and you set the text format with it. And there's still an option. You can set it to auto and say, okay, try to auto-detect it. But usually you want to set it to either plain text or rich text yourself. Another problem with that method was that it had an implicit side effect, because when it detected rich text, it enabled line breaking or word wrapping. With plain text, word wrapping was disabled by default. So a property which should be completely orthogonal to that text format was also triggered by that change. And that's not good. And we said, we did it that way because we thought that's what people want usually. But it really makes it difficult for people to know beforehand what's going to happen. Another example Mark quoted in his talk earlier today is QList, where we have, depending on what kind of objects you put in there, the data layout is rather different. And also that was magic, and people usually don't understand the implications of that, and it's very hard as a developer to know what you get. So avoid these kind of subtle side effects. Another thing is really to avoid implicit conversions. They often come at a high cost, and they're not visible in your source code. So make sure that you mark one argument constructors as explicit all over the place. and make sure that you follow that and try to avoid these kind of conversions wherever you can. It's in a way a shame that C++ makes implicit conversions so easy. I would have wished that the language didn't have implicit conversions, but we have what we have. We can at least try to avoid them wherever we can. Should also pay attention to edge cases and corner cases. And they should follow really a principle of least surprise. Also here it's about what you would intuitively expect. But also make sure that you document them. We had one example here in Qt3. We had a QStringList split method. Actually QString split, sorry, I mistyped there. Where you put in a separator, or no, actually this was a static method in QStringList. And then you put in the string that you wanted to split up, and it had an allow empty entries equals false as a default. And when you then used that one and you split it up, when you had a string with one colon in there, oops, like this one here, and you split it up, you got an empty array back. Was that intuitive? No, because you would have expected to have, what you would have expected is to get back an array with two entries that are two empty strings. That's the intuitive behavior that people would have expected, and it's also the logical one. So make sure that works and the defaults are proper there. Okay, so conceptual things. Let's have a little bit of a look at class design. The first thing to think about it is really, should the user be able to inherit from my class? Is it a polymorphic class or isn't it? That's one of the fundamental decisions that you have to take with your class. Let's say, there are different pros and cons, and it's a decision that you really have to take upon your use cases. The ones where you don't want your user to inherit from are usually, in Qt we call them mostly value-based classes. I mean, most of the STL classes fall under that. Think simple, tools classes like in Qt that we have QString, QMap, hashes. They all fall under that this paradigm of value-based class. It's usually data structures with methods on it. They have no virtual methods, and nowadays I would say consider marking them as final so people don't inherit from them, because that can lead to subtle problems when people then cast them down to the base class. You can consider whether you want to disallow or discourage allocation on the heap to simplify memory management. In Qt we recommend that all these kind of value-based classes are always allocated on the stack. There's no actual need to new them. Also think through, do I need a copy constructor or assignment operator? Because often the compiler default will do. And in that case, it'll usually also do a better job in implementing them as you will do yourself. Can I mark the constructor as const expression nowadays to help me, create that data, compile time into ROM? And do I need a destructor? So these are questions you should ask yourselves there, and also, consider making small and simple data structures immutable. So you create them once, and if you want to have a modified version of that data structure, you have to take a copy. These are things you need to ask yourself and weigh the pros and cons against each other there. In polymorphic classes, you have virtual functions, and things tend usually to get a little bit more complex there. The first thing to do is carefully decide which methods you want to make virtual. Of course, when all methods is usually the wrong answer unless you're really dealing with pure interfaces. So pure virtual classes where everything's an interface, that's different. But otherwise, for most other concrete classes that have also partially an implementation, making everything virtual just throughout because somebody could be using it is the wrong answer, because often it will not work. And why is that? Because the virtual set of virtual classes defines, an interface, a virtual interface for your class. And you have to always go through that virtual interface when you do want to call that method. And if you simply make everything virtual, most of the time, so we've seen that in Qt, we've had that tendency in Qt 3. We also made lots of methods just virtual, just because somebody might subclass it. But then we ended up not even calling these virtual methods ourselves, from the base class. So there was no point in having the virtual. So with Qt 4, we removed lots of these virtuals, and we didn't even get any bug reports because nobody was using that functionality. So really go through, figure out, does this method need to be virtual? It only helps when you call it, from the base class or from somewhere else, in a polymorphic way. If you don't do that, there's no point in making it virtual. Of course, the structure has to be virtual, but that's a no-brainer. Another thing that you can consider is making most of the virtuals protected and, separating the, API for, inheriting from the class from the public API that the user of the class uses. We've done that to some extent, for example, in QIO device. We have a read data method, which is a more low-level method to really read the data in, and it's virtual. And then we have convenience methods, QIO device read, which are public. So the read data is protected. And that helps us separate things and gives us a bit more flexibility on the public API. We can add more overloads without any problems. I mean, overloading virtual methods is usually difficult. So if you separate that, you can easily add overloads to your public API. And when classes are polymorphic, do you really want to allow people to copy them? That also has its share of issues, at least when you use the standard copy constructor. Because if you only have a pointer to the base class, the copy constructor will probably not do the right thing because you slice your class. The way to get around that is to make them protected and then maybe have a copy method in there. Another thing, from my experience, unless you're dealing with interfaces, I would avoid multiple inheritance because it complicates your API design. And what it means is that conceptually, you mix two different concepts. That's what we said earlier, an API should do one thing and should do that well, one concept, implement one concept. If you do multiple inheritance with two base classes, you usually bring two concepts together. And you have to really think about whether that's a good thing and whether this really helps and improves what you're doing. Another thing we're using quite a lot in Qt is static polymorphism, which means, we actually, similar classes have similar API. QString and QByteArray both don't have virtual functions, but static polymorphism means that in the code, I can just simply exchange one for the other, and most of the code will still compile. It'll just pick up that other class because the API is the same. Similar, for example, on the UI side, a QSlider and the Spinbox. They implement similar concepts. You have in a slider, you have something that you can pull left, right to get a certain range. In a Spinbox, you have something where you can go up and down with some buttons or something like that, and you also select something out of a range. So the concepts are very much the same. They look different, but then they can have the same API. And that makes it very easy then later on to go back and say, okay, I rather want that slider instead of the Spinbox because I think the usability is better. And then you just exchange those, and with very little changes to your code, you have done the refactoring. The other question then is, do you need a common base class? We've done that in Qt, in the networking stack. We have a QAbstract socket base class, abstracting a socket. Sounds like a good idea. And we have two re-implementations, a UDP socket and a TCP socket. But nobody ever uses them in that polymorphic way that you just have that pointer to the abstract base class. So in the end, we would have been better off to just have two classes with static polymorphism, QUDP socket and QTCP socket. And where they do the same thing, they have the same API. It's not what we've done, but we should have. So it can lead to a simpler API for people to understand, and you avoid lots of the problems that you get with having virtual functions. Another common mistake is that people use inheritance in the wrong way sometimes. You should only use it if there's a clear is-a relationship. So if something is something else, like a stack is not necessarily a vector, but you can use a vector for the implementation. It's an implementation detail, and by making it inherit from vector, you expose that implementation detail to your users. And people can then use all the functionality from the vector, maybe breaking some of the paradigms of the stack. So that's what you don't want. If something is something else, like a push button is a button, and that one is a widget, that works fine. But in this case, composition is the better choice. What we've been doing a lot with Qt is moving over to a property-based API, because it's a very intuitive model for people to understand. I set certain properties on my object, and then it does something, and then it behaves in a certain way. It comes with its own, share of challenges on the implementation side, because the initialization order is not enforced. So you set the properties, and it usually requires you to do a little bit of caching and then lazy initialization to make this work. But you do have well-defined default values. With that, you can query them all, and you have something where all of these are orthogonal to each other, making it easy to understand again what's happening. Here's a API. This is from Microsoft. This shows clearly why putting everything into the constructor is a bad idea. I mean, I had a similar example before, but you need to add comments to this code to understand what each of the arguments are. We must be able to do that better. So that, this is how we've been doing it in Qt. You say, or how you could do it. You set the class name, you set the window title, the style, the size, and different properties on it. But you create it just as with a very simple constructor. Another thing that I personally believe, but some of you might not, is that at least for classes that are mainly event-driven, signals and slots is a good mechanism to encapsulate things better, because then you don't have to the sender of a signal and the receiver, they don't really have to know about each other. You can just connect them together. When one of the objects gets deleted, the connection gets destroyed. Things are pretty safe. So I like that concept. I'm not sure, not everybody uses it, but there's implementations in Qt with boost.signals, and I think that's something one can consider for a certain set of classes. And finally, really make sure that you hide your implementation and don't expose it and leak implementation details out through your API. A simple example is, I have a class and it has a list of items or a vector of items, and I want to make that expose that. So I have an items method, and it returns a const reference to that vector. Looks great in principle, but you do leak out. And it might be the right thing to do in certain cases. Don't get me wrong there. It might be the right thing to do because it gives you the performance requirements that you have. But you do leak out an implementation detail. And the implementation detail is that you store that list in a vector. And you can't change that later on. Also, make sure that you really make private what you can make private. All data members don't have any direct access to those. Whatever is there, all the methods that you really need as an implementation detail, make them private. Don't, give them out. But as I said, I mean, the most common case where you leak out implementation details is usually through some parts of your API where you basically, returns a reference, for example, to something that's part of the implementation, or a pointer to something that's part of the implementation. That's something you really need to consider carefully whether you want to do that, because it limits what you can change later on. Okay, methods. We were talking a lot about classes now. Let's go a little bit down onto the method level. Also here, clear and unambiguous names are really important. In my opinion, you should also avoid overloading methods unless the different overloads do exactly the same thing. In some cases, then overloading is the right thing. If they do the same thing, give it the same name. But if I've seen many cases where the two methods do slightly different things, and people are still overloading them, giving them the same name. I would also avoid long argument lists because they tend to get very unreadable. Remember that window example from Microsoft? You tend to lose the idea of what each argument does. So then, maybe put some of the arguments in structures that you then pass in. And of course, mark methods as const that don't modify the object. Those that don't have visible side effects, let's make them const. The naming of the method arguments, I believe, is also just as important as the method itself. They should match each other, but they also show up in your documentation and in your IDE and the auto-completions. I would avoid single letter names, except maybe for X, Y, Z or something like that for geometry. If you think about, this example here where we have, I've had that one before with index of. If I name the argument a search string and the start index and not S and I, it's much clearer what they do. And, if the completion comes up in my IDE, I see that and I immediately know what I need to do. If it's S and I, it might be a little bit more tricky to figure that out. So good names also for the arguments is important. Also be consistent in how you order your arguments. This is an example now from C. Memcopy and bcopy. I think most people don't have tried to forget about bcopy, but it's still there around. And they do the same thing. And actually they have the same signature, except for the return value. But the order is different. Now, so if you ever stumble around the B, most people know what memcopy does, but if you stumble around the bcopy and you see it, and you can easily get confused what source and destination is. Make sure you order things consistently there. Also, I think you want to avoid repeated arguments of the same type, because at some point you start wondering which one is which. Except, if it's really clear that, like geometry, that X comes before Y, that's relatively easy to remember. And, I've had that Boolean trap example earlier, avoid that one. Prefer enums instead of, passing Boolean arguments into the function, because people will never know later on what they do. I would also avoid out parameters and rather consider returning a struct. But please, don't return standard pair or standard tuple if you can avoid it. I know it's not avoidable in template code in some cases, but for everything else, don't return it, because it doesn't tell you what's in there. It tells you the type of what's in there, but they're not named. Rather write a small struct that has proper names for the two members that you return. Also, I think it's important to be consistent in how you use values, pointers, and references in your API when you pass them as arguments. In Qt, we have one convention. I'm not saying that's the only one you can have, but at least we're trying to be consistent with that one. We pass value types by value if the object is small enough, otherwise by const reference. Input arguments are usually that are pointers are usually passed as a const pointer. In, out, and out parameters are done by pointers. And I personally believe it's preferable to references. I know many others will disagree with me here. But it has the advantage that it indicates the method. When you read the code later on again, it indicates, it tells you that the arguments might get modified. So if you have that color, get RGB, the get will tell you a little bit about that. But at least, when you then have to dereference R, G, and B, you see that they will get passed in as pointers and they can get modified by the called function. When you pass them in as values, it's not clear. Here, the only indication that you have is the get. But if that method was just called RGB instead of get RGB, you wouldn't have any idea. That's why we prefer pointers in that case. Also, I wouldn't use string as a data type. People end up parsing them and doing weird things with them afterwards. Rather try to encode the information in enums or other, information. And, one of the things I've seen, people tend to still use float a lot. Don't use it. There's no point anymore. Double is just a lot more precise and just as fast on modern CPUs. I had a little bit about return values earlier, but really return by value if possible, not by const reference. As said, if you return by const reference, you might have good reasons for doing that for performance and to avoid copies. But it does expose implementation details, so think twice about it before you do it. Property getters and setters. I've talked about that. I like property-based APIs. So, how do you do them? Usually, prefix the setters with set. That's very easy. Everybody does that, like a set timeout. In Qt, we're doing no prefix for the getters. Others use, Java, for example, always uses a get as a prefix. That's, up to what you like. I prefer without the get, but that's maybe just because it's less to type and it's just as clear. One more thing is that if you have Boolean properties, prefix them with is or has. I know that the STL has that. String.empty and all of you intuitively know it means is empty. It's the question, is that string empty? But it's actually a verb as well. It could just as well mean empty the string. And for other things, so an is empty is much more intuitively understandable when you read it. And that's the convention we have. Is or has for Boolean properties as a prefix for the getters, usually. Another thing that I found very useful is to use flags, bit flags. Usually encode them as enums, and then it really helps reducing the space of what you have. Instead of having 10 different Boolean setters for the different properties, you have one setter for the flags. Like one example here is the set alignment, and you say align left or align top. So you want it left on the top left. In earlier days, we implemented that with an int alignment then, but that wasn't type safe at all. So you can do it in type-safe way, for example, by having an enum alignment flags. What we have in Qt then, we have a type-def qflags. Qflags, if you're interested in it, just look up the implementation, how it's done. That maps it to alignment, and then the Qt text edit actually takes the alignment takes alignment and as the argument. And that makes it type safe, so you can't pass in a different enum or values of a different enum type into the set alignment without getting a compile error. Okay. Another question, another thing, documentation. Good documentation is extremely important, can't be underestimated. It's one of the things we've been focusing a lot on with Qt, having really a good class level, module level, method level documentation. Really explain, what a module does, or a certain framework, what is its purpose, or a set of classes together, overview documentation. Go in, explain every single class with overview documentation, and then every method. Document your side effects, document your corner cases. It's really helping all your users. And examples are also part of your documentation. If you write examples and you put them, somewhere into into your code, people will copy and paste from them. Be prepared for that. So you better make sure that they're good and they do things the way you want them to, you want people to use your API. Also, make sure that you keep implementation and documentation together. Otherwise, they will get out of sync. Document. The best is really if you can document in line with the code. Either in the header files, Doxygen style or QDoc style next to the implementation next to the implementation. It really helps you, make sure that, because then you can easily in one go, when you modify something in the implementation, you can at the same time change and adjust the documentation to document what the new or change behavior is, or whatever you're doing there. As I said, with error handling, I've mentioned that a bit earlier, report them as early as possible. Aim as much as possible for compile time error checking and reporting. Check types, make sure things are type safe. As I said, avoiding implicit conversion is part of that. Use static assertions very freely. If things can't be checked at compile time, then try to do them as early as possible at runtime. Really, add assertions in your code very liberally. You can't have enough of them. And as I said, don't report the errors a lot later after they happened. Because debugging that one is like debugging a free memory read or something like that, where you deleted an object and then it crashes half an hour later somewhere else. You don't know why and where, and it's very hard to debug. Okay, that's also a bit, probably something that not everybody will agree with, but exceptions. As the name says, for me, it's only really about exceptional circumstances. In Qt, we chose to not use them at all. We don't use exceptions in our API or anywhere. We try to play nice with them, but we're not using them. Something that you really shouldn't do is use them for the control flow. I mean, some of you, I don't know if who of you remembers COBA. One person, very few, a couple actually. And exceptions were everywhere in there, and you had to really check everything, and they were done for rather common cases like a disconnect that could happen for a remote procedure call. And what it led to is that when you wrote the code, you had a method call, and then you had to write around 10, 20 lines of glue code around them, and that's what can often happen. So that's difficult if you use them for control, and that was really control flow issues then. But then, the other thing that can happen is if you just use them here and there in in some circumstances, developers often forget to handle them, and if they're not handled, your program crashes. So think about what you can do, whether you want to use them or whether you want to find other solutions there. Okay, one thing I haven't talked about yet is performance. We had the good keynote by Chandler yesterday morning, where it showed us a little bit about what compiler does with your code and how it can optimize things. I think when it comes to APIs, you also have to always keep that piece of performance in mind, but you should also check how important that is for your use case. The largest part of a code base of an application is not performance sensitive. Usually, you have some inner loops, some places where you spend most of your time. And in most cases, I mean, you should really prefer readable code over let's say, something where you really fully optimized is maybe wrongly said, but where something where you basically introduce very, very complicated to use APIs for the sake of that performance. Because your users will in many cases get that wrong anyway. I've seen that. We've tried to do APIs that help and make things very performant, and then users use them anyway the wrong way. And often you'll end up optimizing the wrong use case if you didn't really clearly measure that this part is a bottleneck. So, a simpler API, if you can hide the complexity, will in the end, often lead to more performant code by your users. So, if you really need it and if it's required, then, spend extra time, really analyze the use cases. How are your users using the API? And see what you can do then to, fix the bottlenecks. There's things you can do that are easy. For example, if you create a shared library and people are using a certain function call in the for loop, like, the size of a container, and that's not inline, the compiler will not be able to remove that function call. It will call it in every iteration of the loop. If you make that size inline, there's a good chance the compiler can pull it out of the loop and only call it once, depending on what you do. Or, you need to be aware of that limitation and pull it out yourself later on as a user anyway. I've had recently a discussion on the Qt mailing list about this one here. We're passing strings into our API in many places. For example, this one. Now that's all good and fine, and there's no big performance penalty here. But what happens if you do this now in C++ 11? Oh damn, we need to create a Q string here because that's what the API takes. And that's a memory allocation, so it's sort of expensive. And we had a lot of discussions there, and I think similar things I think happened also in the C++ community with similar things. So there's discussions ongoing now. How do we want to fix that in the longer term? Like using a string view there that can take both a Q string and that raw 16-bit string and pass that in, and we solve the problem without having to use many overloads, because currently we're using a couple of overloads. That's not really very nice. So these are things where we could improve in the future, and I think we will also do the work there in that respect to move towards that in the future. But the big advantage is we can still do that now. It wasn't there in the beginning. It's a new requirement in the end, or a new idea that we got, and then let's add it later on. Okay. One more thing about APIs is evolving them. You did your first version of your API, you released it to your users, and people are happy. But they say, I'm missing this and I'm missing that. Can you help me? Can you add some more things to it? And now the question comes: what kind of compatibility promise are you giving to your users? We, with Qt that are doing frameworks, we give usually a very strong source compatibility promise. We do break that between major releases a little bit, but we try to keep it as much compatible as possible. And there's a binary compatibility promise. And that's source compatibility basically means, I can take a newer version of the API, and my code still compiles against and runs against that version when I recompile it. Binary compatibility is a stronger guarantee in the sense that if I go in and I have my application linking against the shared version of a shared library, I can take that shared version of the library, replace it with a newer version, and everything still works. Magic. But both of them have different requirements on what you need to do, and you need to understand what your users are doing with your library to know what you need. In most cases, most projects, probably source compatibility is more than enough. So, what can you do with source compatibility? It's actually pretty easy in that case. You can't remove methods. You probably want to do some managed deprecation in case you want to get rid of something. So basically, mark a method as deprecated or a class to make sure the compiler starts warning about them. Have that for a couple of times, and then at some point, when you made sure that all your users moved over to the new API, remove it. Same thing, classes. One thing you have to be a little bit careful is when you add overloads for existing methods. This can lead to ambiguities, and we've had that case a couple of times in Qt when we had a method that took an int and we added an overload taking a long, and suddenly, you got ambiguities because you had a different type that, which one should it convert to. So you have to be a bit careful there because when you add these overloads, does it break my code and my user's code? Maybe it's often easy to solve them, but be aware of that at least. As I said, with binary compatibility, the new version of the shared library is a drop-in replacement. It's stricter than source compatibility, but you can actually break source compatibility and still keep binary compatibility with some tricks. One way of that is basically, for example, when you compile your library, you have all the methods available, but then when by switching on a certain define, so you hide certain methods behind the define, and then when you run it, when you ship it to your users, that define is not on, so the methods are not visible in your header files anymore. And suddenly the users can't use those anymore. Other ways, there's other more subtle ways. But usually when you keep binary compatibility, you usually also tend to keep source compatibility. And you have a lot more stricter requirements there. You can't change the sizes of your objects. So if you have that requirements, you need to really think about what you'd want to do, because you have an object, adding a member variable to the object is a no-go. You can't do it because it changes the size of your object. And the compiler assumes a certain size of that object when it puts it on the stack, or when it uses it on the heap. So that would break horribly. Also, classes that inherit from that class would have a wrong memory layout. So anything that changes the memory layout of your class is usually something you can't do. What we're doing in Qt there is the pimple scheme depointer. So we're putting all the implementation into a hidden private class, and all the data lives there. But there's other things you can't do. You can't add or remove virtual methods. Also, that changes the layout of your vtable, which just as well breaks things. You can't reorder them neither. So if you think in your header files, looks bad, I want to move some method further up. If that method is virtual, you're most likely breaking binary compatibility. And you can't change anything that's being accessed inline, any data members. But here's some tricks that you can do. If you don't change the size of the object, you can sometimes, in some cases, basically repurpose a data member, as long as it's not accessed inline anywhere, but it's only accessed from within your shared library. We've done that in Qt a couple of times, where we said, okay, here we have a data member, then we did some optimizations or some changes. We didn't need that member anymore, so we had, for example, one integer that was unused. And then we could start using that for a different purpose again. Or another thing that some people do is they reserve a bit of space in their object, for future compatibility. So they add, one or two void stars that you can then use later on and put some data in there. Only trick there is make sure you're initializing them to 0 or something like that. Same thing, some people have been in the community using tricks to add 1 or 2 dummy virtual methods. So you reserve 2 slots in the vtable and then later on repurpose them. These things you can do, but they're all pretty dirty, and they might fail on certain compilers. Especially when you do these kind of vtable hacks, I think the Visual Studio compiler are a little bit sensitive there. Works nicely on the other ones. So, a little bit of closing comments, and then I hope I'll have some more time also for questions in case you have some of them. I think one of the things really that's important is to keep it simple. I've seen, and one of my goals when we're doing Qt is always to also make it easy for new and intermediate developers to get in, to start understanding the API. Keep the effort for people to learn your APIs to a minimum. If you have a low barrier to entry there, it's much easier to get more people to use your things. Also, your project rarely only has C++ gurus. So, you might have some other people who come with another background. Maybe their main programming language has not been C++ in the past. And we all know C++ is a very complex language. It's very powerful as well, but most of that complexity is only required rarely in some parts. And there, of course, you use it. You use all the power. But you can make 99% of the code. Maybe that's a little bit exaggerated. In some cases, maybe only 90% of the code. But most of your code, rather self-explaining and easy to write and easy to read afterwards. And that's what you should aim for. And finally, whatever you do with an API, you'll never please 100% of the people. You will always find somebody who has something, wants something new, something else. It's not a problem. Live with it, and just make sure that people using your API have the means to implement what's missing by themselves. That they can work with your API and extend it by writing some code themselves to do what they need it to do. So, and I think with that, I'm happy to answer any questions that you have. Thank you.
You said that you are not using exceptions, so you're very generous with assertions, which is great. What other tricks are you doing in order not to use exceptions?
It really depends on the use case. I mean, often, we do things where if possible, we encode, that circumstance in the return value, and make people just, query that one. That's the best possible solution if you can do that. It's not always possible, but that's the best solution. Otherwise, if you're on a class, if you have a class, I mean, the class could have an error state that we're then using. What we often make then possible is also that you can use the class in a way it will not, once it's in an error state, I mean, the other methods will, you can still call a couple more methods, and you can then query at some point the error state, and you know that, okay, something has happened, and then you can print out something to your users. It depends, really.
And you do this avoiding of exception in order for get a greater performance, or just for future usability?
If I do what for getting greater performance? I'm sorry.
Avoid the exception.
Exception is not. It's not about performance. I mean, exceptions, handling nowadays. I mean, as long as you don't throw one, it has zero overhead. It's mainly about maintainability of the code, in my opinion, in the long term, and try to use it in the good ways so that you keep things maintainable.
I wanted to ask about logging. How much should we do it with API? Where should we log? What should we log?
I don't think there's a clear answer to that. It really depends on what you do with your use cases. I mean, initially, when you do a new API, I think adding a lot of possibilities for logging is a good thing. So I would often do that if that helps you. Especially if you ship something off to end users and they have some failures and you need to trace back what happens. Having a switch to turn that on and really know exactly what's happening is often very helpful. On the other hand, if you have full control and you're doing that project, you're not shipping that off to users, but you're maintaining the system yourself. You might not need that as much, and because you can always step in with the debugger.
You talked about that you like property-based interfaces.
Yes.
Are you considering maybe a builder pattern where you set the properties before, but have full control of the lifetime? I mean, you can hide it with a property-based system that you initialize your internal state only when it's really needed.
Yes.
But making it explicit might be beneficial. So if you create a window, you don't have to update the window, but once you create it, you have all the setup in a builder system.
Yeah. I mean, this is something that you can do. For example, if you put all the whole initialization list into a data structure and then pass that off to the constructor. I like that concept just as well. But I think you still want to have at least afterwards the getters to query these properties.
Yeah, hello. I also have a question about property-based API. I'm very curious to know your vision because we hear a lot about functional style programming, immutability, like you don't know setter on your classes, and copying, creating everything in the constructor. So somehow your presentation is maybe not conflicting, but in my opinion, balancing this view. And I would like to know your feeling about this, maybe tendency to avoid setters today and in promoting immutability in terms of readability of code as well.
I think it depends on what you're doing with your class. You know, I do like also the functional style, but and you know, for many of the things that's happening in the C++ standard, if you look at compile time evaluation and these kind of things, you can only do it that way, right? But I think, you know, if you have more complex classes, especially what we're doing often, you know, UI objects that are living in the UI and these kind of things, you need to modify the state of these objects anyway. So in that case, then, you know, you can't have immutable classes, and then, you know, the property-based system is very good. If you have something like a class like a point or something like that, yeah, if we were to redesign Qt from scratch now, or do it now, I could also consider making those immutable and initializing everything in the constructor. But as I said, I mean, the problem comes when, you know, you start having, you know, 10 arguments to the constructor, and then, you know, the readability of your code suffers. So up to 3-4 arguments, things are usually okay. When you go above that, it starts getting a bit, you know, you have to find ways to keep things readable.
Yeah, so for me, just to thank you, it was another vision who balance this argument that functional style is more readable. Then I suppose it depends, and thank you for giving examples to balance that.
You're welcome.
You showed us an example where you had an method items which returned a const reference to a Q vector, and you said that it's a bad idea to do like this, but when you have such a situation when you have a sequence of items and you want to access them, what's your advice of doing this if we don't do the getter like you showed?
I mean, as said again, you need to weigh two things against each other there. I mean, if you do that, what I said is you have to be very aware that you're leaking your implementation detail through your API. So that limits the amount of changes you can do to your implementation later on. It still might be the right thing to do because, for example, having that direct access, you know, gives you a lot of performance benefits. But in some cases, you know, you want to rather hide the API to be on the safe side. And what we've done in Qt there is, for example, that we then added methods that the class that instead of having a container that returns all the items, you basically have an API that gives you item add and set item add and num items and these kind of things, and then you can work that way around. And or maybe that you implement some iterators on top of that class that help you iterate through things.
So you can have in your class begin and end methods and adapt it to
why not?
For and so on. Okay, thank you.
Hello. Every time I program Qt, it grates me that I have to use QStrings, QVector, and not standard types. Can you comment on that? What is the reasoning of replacing perfectly fine standard type returns?
Well, the reason is that we haven't been replacing them, actually. QString and QVector are two different types. I mean, QVector nowadays, if I were to start Qt from scratch nowadays, of course I would use the standard types. Now, Qt started 20 years ago, and at that point in time, you know, they didn't exist and or were extremely bad, and that's why we implemented our own data types and our own tooling. And nowadays, you know, we have, you know, hundreds of thousands of users using that things, and probably, you know, billions of lines of code that use these data types. So removing them is not exactly easy. That's what I told you. You know, once you have an API, it stays. It tends to stick around, and you can't easily remove it. So, we have to think about what we want to do in the future. And, I've been discussing, for example, with Mark earlier and with others in the Qt community. What do we want to do when moving into the future? Maybe, we just want to, move that over. Maybe QVector can use a standard vector as an implementation, and then you have an easy and fast conversion. But we currently, without breaking compatibility, meaning, the move to Qt 6, we can't do that. But we have to see, what can we do without breaking too much of our users' code. But, I mean, I understand the problem, and, yes, nowadays I would use standard vector. When it comes to QString, the STL has nothing that can compare with QString. There's no class in the standard library that can do decent and proper Unicode handling. So there's no replacement currently for QString, and we will continue to have it. And the Unicode handling that you need to do, there's a lot of things that actually you need to implement. So it's actually not an easy thing, and you also need to see how you want to move that forward, because the Unicode standard is updating itself at least once a year. So we end up updating our data tables and all the things that we need there once a year. So I think QString is a great class in that respect, because it does solve a real problem that is not solved elsewhere.
You were discouraging large constructors and had the example with like 8 ints behind each other. Yeah. Those aren't really ints. Why not use the type system to improve clarity rather than a property-based interface? Because if you had like columns, rows, X, Y, height, width,
yes, you can do that.
Then it would be clear again.
I mean, that's one of the possibilities you can do to improve the constructor. So what you could do, I mean, I had that slider example, and then you could have, but it requires you to then add lots of helper classes. So you could say, for example, I create a new slider with, and then, the first argument you pass in a range or something like that, and then it becomes very clear what, the two values in that range are. And then the other arguments are things like that, composite types as well. So that's a possibility, and, that can also work very well.
It seems to me that it would be less typing for the user, more performant, and less library implementation. Because, they just be, strong type aliases. It's just a template. You're using it and calling it height.
We need to be able to, it's not, at least not less library implementation, because we need to be able to have the setters anyway. You need to be able, for example, for a slider to change the range anyway. So the setters are still required. We will not get rid of those.
Yeah, okay, but you have to have like a lot of deferred initialization, because you don't know those to begin with in the constructor. So you have to do defaults first, and then...
It's a choice we made, and we, at that point in time, it helped us a lot with readability. I mean, that was also, some of these choices were done, with C++ 98 in mind. The syntax can be nicer with 11, I think. But I mean, the point is, you would have to put in there then, that range, you don't want to put that into the global namespace, you would have to put that as a subclass into QSlider. So you would say new QSlider with QSlider colon range of, 1, 10,
yeah.
and so on. And it would also get rather long in terms of typing things. So,
okay.
But it's it's certainly a valid choice to make.
So you had the one example with QArray in Qt 3D, I think, and
yes.
As a naming conflict, or that you should use proper names. What do you think about using namespaces, as Qt does not use a namespace? Would that help, or are you?
Actually, Qt 3D is using some namespaces now. Historical reasons why we're not using them again, because we haven't, they were not available when we started off, and we've been thinking about, whether we want to move them. The problem was, at least when we went over to Qt 5, still that just putting things in the namespace still, breaks some compatibility. So we had to think about how we want to do that, especially our users using, just forward declarations. Then you have to rewrite all of those to put that into namespaces, and we wanted to make the move very, very easy at that point in time. something we can again reconsider with Qt 6. You know, it would also be great if C++ helps us there a little bit more to make that easier. You know, one of the things we have also been thinking about is, can we, instead of, you know, having Q slider, have a Qt colon slider or something like that? And as I said, I mean, one of the problems is forward declarations, all of that breaks. But maybe, you know, we can solve that much better nowadays because, you know, we can actually use things like Clang and the Clang libraries to create something that can rewrite all of this, you know, automatically for the user. With a, you know, we had that for Qt 3 to Qt 4. We had also some tool that was a Perl script, and you know, it got it right 80% of the time, but you know, unfortunately, it also got it wrong, you know, 20% of the time. So that wasn't a good solution. If we have something that where we can, you know, we can really parse things well enough to understand what's being done and then rewrite things in an automated way, then we have much more freedom. And maybe that's a choice that we can do for Qt 6. Okay. Any more questions?